Hello, Professor Sargent here with you again. I recently saw the problem that was just showing on the channel of the creator Learn Communalizer. Not sure if I pronounced that right. Hopefully I did. He had this question and had a very neat solution to it. I thought I'd try a different solution, which I thought was going to turn out to be a bit of a mess, and it was actually nicer than I thought it would be. He did a lot with factoring, and I was inspired by a comment that someone made that made me start thinking about means, arithmetic means, or what we would call in the United States averages. So here's what I'm going to do. I'm going to multiply both sides by 64. That's an equivalent equation. Why 64? Well, that's 2 to the 6th. And hopefully you know that when you multiply two things that have the same power, you can bring those things together like this. So the power of a product is equal to the product of those powers. Then what we're going to do is, well, besides distributing there, find a new variable as the average of the two things that are inside. And that would give me, in the numerator, 4x minus 2. All of that divided by 2. Dividing by 2 is the same as multiplying by 1/2. So if I distribute that, I would have 2x minus 1. Okay, let me do a little erasing here. But u is equal to 2x minus 1. Therefore, 2x, that's u plus 1. Whereas the 2x minus 2 take our 2x minus 1 and subtract another 1. That first two terms there, 2x minus 1, that's equal to u. Therefore, replacing 2x here with u plus 1, the 2x minus 2 that we had raised to the 6th power, you saw that a moment ago, with u minus 1, all of that raised to the 6th power. Learn Communalizer's approach was do factoring. Instead, I'm going to multiply things out. How? Do you really want to raise something to the 6th power? Well, we have binomials here, and perhaps you know about binomial coefficients, or at least a shortcut to that, Pascal's triangle. When you raise a binomial to the 2nd power, you would have, for example, if that's a plus b, that quantity squared, you would have a squared plus 2ab plus b squared. And the thing about Pascal's triangle is that you are going to have ones along the diagonals, and 1 plus 1 is 2. So if you raise a binomial to the 3rd power, ones along the diagonals, and 1 plus 2 is 3. Ones along the diagonals when you're going with a binomial to the 4th power. 1 plus 3 is 4. 3 plus 3 is 6. 4 and 1. Okay, so that gets us up to the 4th power. 5th power. And finally, 6th power. So with the quantity u plus 1, all of that to the 6th power, I'm going to use these coefficients. And then with the u minus 1, all of that to the 6th power, I will see pretty much the same coefficients, except that when you have an odd power, the sign is going to change. So u plus 1, all of that raised to the 6th power. We've got u to the 6th plus 6u to the 5th plus 15u to the 4th plus 20u cubed plus 15u squared plus 6u plus 1. With that equaling u minus 1, that quantity raised to the 6th power. Everywhere that there is an odd power of u, we'll have the opposite sign for the coefficient. Because this side is equal to this side, we're going to get a lot of cancellation wherever we had even powers of u. Then if I add all of these odd powers of u over to this side, we'll have 12u to the 5th plus 40u cubed plus 12u, and that would equal 0. Next, we can factor out not only u to the 1st, but furthermore, we've got a numerical common factor of 4 here. Before I started writing things out, I wasn't so sure how this quartic was going to look. It's actually not too bad to deal with that. Because we don't have u cubed or u to the 1st, we're actually looking at something that is quadratic type. If you've heard of the AC method, followed by factoring by grouping, besides the fact that I'm going to set for u equal to 0, as for that second factor equaling 0, 3 times 3 is positive 9, and positive 1 and positive 9 have the same product, but also add up to 10. And we can use factoring by grouping there. Factor out a u squared here. And here, factor out a positive 3. Oh, forgot a u squared there. Okay, so factoring out a positive 3. Because I picked the right pair, the 1 and 9, both have the same product as 3 times 3, positive 9, but also add up to that coefficient of the middle term, positive 10, then 3 times the quantity 3u squared plus 1 takes care of the 9u squared plus 3. Going to do a little more erasing here. So we have either 4u equals 0, or, because we've got 3u squared plus 1 in common there, and what that's being multiplied to is u squared plus 3. That's equal to 0. So for u equals 0, or u equals 0, or 3u squared plus 1 is equal to 0, or u squared plus 3 is equal to 0. No need for the quadratic formula here. You can just use the square root property. If your question is only looking for the real solutions, then we would be stopping here and using just u equals 0, going back to this. But if we're allowing for complex solutions, u is 0, or u equals plus or minus the square root of 1/3 times I, can't forget the plus or minus, or u squared equals plus or minus, u equals plus or minus d squared of 3 times I. So let's go back to the fact that u is equal to 2x minus 1. Two x minus 1 equals 0. Gives us that x equals 1/2 is one real solution to this. Needed a little more room there. 2x minus 1 equaling the plus or minus square root of 3i. We'll have the 2x equals 1 plus or minus square root of 3 times I, and then divide all of that by 2. That gives us one real solution and two complex solutions so far. I haven't dealt with this part yet. I'm going to rewrite that a little bit. Inside that square root, I could multiply top and bottom by 3. Split up the division. And take the square root of the 9. So we have another two options for u is plus or minus square root of 3 over 3 times I. So 2x minus 1 is equal to that. Add the 1 to both sides. And then rather than saying that I am dividing by 2, which would leave fractions inside of fractions, I'm going to say that I'm multiplying both sides by 1/2 and distributes. Which would give me that x is equal to 1/2 plus or minus square root of 3 over 6 times I. What do you think? Is that a pretty slick solution, or did I make it more complex? Then Learn Communalizer. Let me know what you think. Maybe Learn Communalizer will let me know himself. Thank you, and have a good day. Stay safe and healthy.